Hello everyone. Today we will have all of the lessons left for the science. First we start with lesson 3. It's the particles of the matter. So, what's meant by particles? Particles is the smallest building unit of the matter, or it's the tiny parts that made up the matter. Tiny means very small. To see the particles or the tool which is used to see the smaller particles is called microscope. We have a kind of microscope called normal microscope, like as you can see in the picture here. This is the normal microscope. It helps us see the small particles or of the matter, so we cannot see it by our naked eye. We can say also that the particles of the gold is different from the particles of the iron. So the smallest building unit of the gold is different from the smallest building unit of the iron. Also the particles of water is much different than that of the milk. Size of the particles depends on first the type of the particle. So if you want to say the size is much different from the other sizes, we can say that it depends on the type of the particle, whether it's gold, iron, water, milk, or whatsoever. The connection between particles also makes it different in the size of the particles. So and the average size of the tiny particles, one of your hair, from 150,000 to 300,000 particles. To see one tiny particle, such as one blood cell, the scientists used a different microscope, which is called electron microscope. Electron microscope because it's more powerful than the normal. The normal cannot be used to see the one blood cell particle, but we can use in that case the electron microscope. And here is the picture of the electron microscope. Particles of the solid, particles of the liquid, particles of the gases. We are going to make a comparison between the three particles of the three states. First, we can say that in case of the solid, the particles keep their shape. When they vibrate or move, they can vibrate around their places. And they are held together like that, as you can see in the picture, that they cannot slide over each other. That's much different in case of liquids. They held the liquid together, but more loosely than the solids. There is some spaces between the particles, as they can move faster than the solid particles, and also they can slide over each other. Okay? In case of gases, it's totally different. They are not held together. They can move very quickly in all directions because the spaces between the gases particles is very wide. How we can show that the particles exist? We have a balloon. When you blow up a balloon, the particles of the air inside the balloon can move quickly. But the particles of the air hit and bounce to produce a force that inflates the balloon and gives it a round shape. So, what will happen if we try to squeeze this balloon? If we try to press on it, the particles will become together, and so the balloon will get smaller. That explains how the particles fills all of the shape of the balloon. Okay, maybe after a while it will blow up or it will pop up. Okay, so that the particles is trying to escape. When a cup of ice, here we are going to make an experiment. When a cup of ice cube is placed on a table exposed to the sun in a hot summer day, first the sun will heat up the particles of the ice cube. So, like that picture, ice cube in a cup, and then we left it in a table in front of the or in the presence of the sun. The sun, of course, will heat the particles of the ice cube. And what would happen if we give these particles the heat energy or the energy? The particles will move faster and it turns to water. After a while, the sun will still heats up the particles of water, so they move faster and then the water will evaporate. You will not see any water in the cup, so that's why we can say that here is the evaporation because the water particles evaporate. The next lesson is about the models. What's meant by a model? And this is a very important definition. Model is a copy similar to the real things. Models can represent very big things in a smaller size, like the model of the Earth, which is called the globe. Globe represents the model of the Earth, which shows us what? First, it shows us the shape of the Earth and how much the Earth is covered with water. Okay, and also shows us where different countries are. So we want to know, or we want to study or study the locations of the countries and the oceans and all of that. We can use the globe to see all of the shape of the earth and how much the earth is covered with water. Here is the picture of the globe. So the globe is the model of the earth. And what's meant by model? It's the copy that's similar to the real things. We have a model about the solar system. Okay, solar system is a very big place. Planets and the earth are very big objects too. So we cannot see it with our eyes. So that's why we can use the model. Model of the solar system help us to see the planets at once and compare between the planets' volume and which one is closest to the earth. Model that can help us understand how things work. We can say an example of model of an airplane and a model of a volcano. The model of volcano, the shape of volcano and how the liquid comes out of the volcano during the eruption. Like as you can see here, we can make a model about volcano to see how the eruption occurs or the shape of the volcano. It's like a mountain and so on. Model of the airplane also, it's a model to understand how the things work and how it flies up in the air. Model that represents very tiny things in a bigger size, like the model of the germs. The shape of the germ without the microscope and see the different parts of the germs which help them to spread from one person to another. Like this picture, it's a model of the germ. So it shows us how the germs can transfer or spread from one person to another and the shape of it. Modeling states of matter. So if I want to make a model about the states of matter, solid and liquid and gas particles. So it's a tiny particles, it's a tiny objects. We cannot see it with our eyes, but we can make a model about it. So like that one. We can say that the solid particles are close to each other, while when they are much far away, loosely attached. So we can say that's a liquid. When they are very far away from each other, so that's called the gas. The arrangement in the particles in the solid, liquid, and gas, we can say that the solid got a regular pattern that we are comparing according to the arrangement of the particles. In case of solid, we can say that it's a regular pattern. In case of liquid, we can say it's a randomly arranged. It means not well organized. In case of gas, they are randomly arranged also. So what's the importance of the model? Why the models is very important, as it helps us to let us know or learn more about the things so we can see and understand how the things work and learn about many things at just the right size and know what we could not otherwise see. Here is a point of comparisons between solid and liquid and gases. We can say first the spaces between the particles according to the solid, they are very close. In case of liquid, we have said before that more spaces but still close. In case of gas, a lot of spaces and they are loosely attached. What about the energy? We can say that they have more energy in case of the solid. The least energy in case of the solid and less energy in case of liquid and a lot of energy in case of gases. because the energy of the particles make them move freely. In case of gas, they can move very freely. In case of solid, this is a mistake, they have least energy because they cannot moves or vibrates freely because the spaces is too close. The movement of the particles here we can say at case of the solids vibrates and move around their places. In case of liquid they move faster than solids. In case of gases they can move very freely. Point of comparison for the spreading of the particles. In case of solid they cannot move from one place to another, they cannot slide, but in case of liquid they can slide over each other. In case of gas they can spread out to fill up the containers. Arrangement of the particles. In the solid, regular pattern. Liquid and gas, randomly arranged. In case of the shape, the solid got a definite shape, but the liquids and gases non-definite shape or no definite shape. For the volume, solids and liquid definite volume, but in the gases it's not definite. Definite means fixed. Scientists chef used the science during preparing dishes, as the chefs used different states of the matter to change the ingredients, such as if we add some water in a pot or in a pan, and we start to heat it up, the boiling point or the boiling water to cook the pasta or rice, where the water liquids changes into steam in a gas matter. Also the freezing vegetables to keep them fresh. Also when we leave a cup of juice or milk in a freezer to change the state from liquid to the solid. So that's how the scientists use the chefs use the science. Here we're going to study Unit 2, first lesson. We will start by how we use the materials that is suitable for each function, so the people can use to make the roofs of their home and buildings that depends on the climate. First, we can say the environment, which is the desert, okay? Desert home, the material used by people to make the roof is made of strong stone. Why? Because the properties of that, it protects the home from the dust and dirt, and also it's flat. So that how to keep them in safe, to keep the people living in that home in safe. So what about the cold weather areas? The material of the roof is made from ceramic tiles, like ceramic bricks, and it's why we use this material as the property. We can made it in a shape of slanted or inclined, so it protected from the rain and from the snow. In tropical rainforest homes, we can say that we can use the material to make the roof from leaves and sticks. Why we use it from leaves and sticks? It's also is slanted or inclined, like triangle shape, and it protect the home from the animals to go inside. Matter can be described by color, shape, odor, size, and texture. Each property of matter has its measuring tool to be measured. First, if we want to study, or we want to define, or we want to measure the volume, we can use the measuring cup. The length, we can use a ruler for small objects, or a measuring tape or tape measure for long objects. Mass, we can use a balance or a scale. Temperature, we only use the thermometer to measure the temperature. In this lesson, we are going to study the properties of the matter. First, we can say that we have something called physical properties. What's meant by physical properties? Physical properties like color, shape, odor, texture. We can observe the physical properties by the matter, and we can describe the physical properties like, is it rough, is it sweet, is it round, is it blue? Okay, so physical properties studies the that options: color, shape, odor, and texture. But if you want to talk about the ability of the object to burn or the ability to rust, this is a chemical properties. It's not physical. It's the second type, which is called chemical properties. What happens if we tried if a piece of paper interact with the fire? The paper will become ash, as we all know, right? And what would happen if the iron nail interact with water and air? It will rust, as you can see in the picture. So two chemical properties here: the ability to burn and the ability to rust. This is a chemical properties. Comparison between volume and masses. The point of comparison here starts with the definition between volume and mass. Volume, it's the amount of the space taken by this matter, while in case of mass, it's the amount of the matter. The amount of the matter is mass, but the space taken by the matter is the volume. What about the measuring units? Measuring units here, in case of volume, it's liters, and the smaller unit is called milliliter or cubic centimeter, and in 1 liters equivalent to 1000 milliliters, which is equivalent also to 1000 cubic centimeter. 1 liter, 1000 milliliter, and 1000 cubic centimeter. Also, we have a measuring unit for the masses, which is grams and kilograms, and 1 kilogram is equivalent to 1000 grams. Examples for the volume: we can say a bottle of water contains 1 liter of water. But in case of mass, we can describe it with the paper clip has about 1 gram of mass. If we try to make a definition for the temperature, we can say that to measure how quickly the particles in the matter are moving. So I'm now describing or measuring the temperature, how the particles are moving, how the speed of the particles is moving. Quickly moving particles produce more heat energy than the slower moving particles. So if they can move or vibrate or spin very fast, they will produce heat. So that's the temperature of the matter. When the particles can move or vibrate faster, so it produces some heat. So this is the temperature of the matter. And when they are cooled down, or when they are moving slowly or slower, so they get the energy will be lost. So it becomes cooler. So also we can measuring the temperature. Give reason: ice floats on a water surface because the ice is lighter than water. So I'm comparing the masses here. Here is a solid above a liquid. Why it's not sinking? Why it's floating? Because the mass of the ice is lighter than that of the water. By changing the shape of the material, this does not affect the mass. So if I have a scale and I put above it an aluminium foil, okay, it will give me a reading like 2 grams. If I try to the same aluminium foil and I'm trying to change the shape of it, it will be also the same mass, 2 grams. Kindly be noted that the biggest mass materials does not have largest volume, and the largest volume material does not have the biggest mass. As we comparing now as you can see in the picture, bigger masses, bigger volume, that doesn't mean that it got a bigger mass. Maybe it's big, but it's light. We can see like this red ball, it's a very light ball than the black one. Inflated balloon takes larger volume than the iron balloon, and the iron ball, larger volume than the iron ball, and the iron ball has bigger mass than that of the inflated balloon. So as you can see here in the picture, we have a scale or a balance. We put an iron ball and balloon. Which one is got the biggest mass? It's the iron. Okay. And it got a less volume than that of the balloon, but the mass is bigger. There are two types of the materials according to the magnetic attraction. If you want to describe the matter according to their magnetism or the magnetic attraction, we can say some of the materials can be attracted and other cannot be attracted. What kinds of materials, or what's the name of the materials that is attracted to the magnet? We have iron nails, paper clips, okay. And what about that materials that do not attract to the magnet? We have wood, stone, and cork. There are two types of the material. If we want to describe how the materials deal with water, or the matters deals with water, some of the materials will float and some of the materials will sink, and that doesn't depend on their masses. The materials that float on water surface, it means it does not sink, it stays above water, like wood and cork. And the materials that sink in water, like iron nails. Here we are going to talk more closely, have a closer look about the helium. Helium, we can say it got physical properties and chemical properties. Physical properties for the helium is light gas, which is lighter than the air, and it is used to fill the balloons and also used to fill the plimps. And the chemical properties of the helium, it's not poisonous, okay, safe, and it's not flammable, cannot be burned. What about the copper? Copper, it can be shaped into thin, flexible wires, and it's a good conductor of heat and electricity. So good conductivity here for the copper. The uses of the copper, it is used to make electric wires, as it's flexible and good conductor of electricity. So I can shape the wires and I can transfer the electricity from one place to another by this copper wires. And it is used to making the cooking pans, as it's a good conductor of heat. So I will use it to make the cooking pans. In concept 3, we are going to make comparing changes of matter. The mass of any matter do not change by changing their state, whether it's heated or cooled or mixed. So after changing the ice to water, the mass does not change. And mixing matter with each other do not change its mass. So the mass of the fruit before cutting them down equals to the mass of them after making a salad or fruit salad. We have to study the word or the term or the definition of melting. What's the melting? It's the process in which a matter is changed from the solid state to the liquid state. And that's important to know when changing the state from solid to liquid, this is called melting. And of course, this will happen by increasing the temperature, by heating. So the ice will be water by heating, so it changes from solid to liquid, and also the ice cream, and that's called melting. So heating is got another name or another definition, which is called thermal energy. Thermal energy, heat is not a physical, by the way. It's not a physical. It's a form of energy. So that's why we can call it thermal energy. So if you want to describe the heat of the objects, we can describe the thermal energy, because the heat is energy and it's not a physical property. When we use thermal energy in many things like warming and cooking food, as you can see, here is the picture of particles in case of adding or having thermal energy. Here's some notes. First, particles in matter have energy that makes them able to move and vibrate. When the matter absorbs more thermal energy, it moves and vibrates faster and get away from each other. When the matter is cooled, the particles move slower and comes close to each other. And the light energy is like thermal energy. When particles of matter absorbs them, the particles will vibrate and can spin faster. So changing from solid to liquid to gas, like ice to water and to vapor, we can make this by changing the temperature, changing the thermal energy, changing the heat energy. So by adding the heat, ice will change from solid state to liquid state by melting. by adding another or continue in adding thermal energy, the liquid will be evaporated by evaporation to be a gas. So by losing this heat or losing the thermal energy from the gas to be liquid, we will make condensation, changing from gas to liquid. While in case of changing the state from liquid to solid, this will be by a process called freezing. Water vapor is different from the steam. The water, when the water boils, it produces water vapor which is invisible in the air. But the steam is visible because when water vapor hits cooler air, it condenses. Means that it makes a condensation process into tiny water droplets which is visible as white clouds. Physical change. So we talked before about the physical properties. Now we are going to talk about the physical change. We have to know first the term of the physical change. What does it mean? It's the change in the matter without the changing in its structure. So when we change the matter without the changing the structure, so that's a physical change. So when the chocolate melts, it changes from the solid to liquid, but its taste, color, smell doesn't change. So that's a physical change. Also by melting the ice and freezing water. So that's, we are going to change the state, but we are not changing the structure. Okay? The physical change are usually reversible. Reversible means that we can get it back to its original state. Such as the melting, it's a reverse process. Lesson 3, we are talking about the mixture and the compound and the difference between them. We have first the mixture, it's the matter formed of two or more materials, while the compound is the matter formed of two or more materials also, but in case of the mixture, they cannot combine chemically, but in case of compound, they combine chemically. It means that it can form a new substance. Mixture, like first we have the solid materials like sand and rocks. Now we are making mixture, not a compound. Fruit salad. Okay, here is the picture of a sand and rocks, and here is the fruit salad. We also have the solid and the liquid materials, which is salty water formed by dissolving salt, solid in water, which is a liquid. 3, we have gas materials like the air. Okay, so this all is called the mixtures. Some mixtures can be seen by eyes and other cannot be seen, like the air. It's a mixture of gases, but we cannot see it with our eyes. Properties of the mixture. It consists of two or more materials, and all of the materials that form the mixture do not combine chemically. Each material in the mixture keeps its properties, and the sugar, so we can say that the sugar doesn't lose its sweetness when it dissolves in water. And if in the fruit salad, you can identify each type of the fruit salad in this plate. The component of the mixture can be separated after mixing them. How we can separate the mixture? First, we have a process called filtration, like as you can see here in the first picture. Filtration used to separate a mixture of one material which has smaller particles than the other, such as the mixture of the water and the sand. And we have a process called evaporation, which can separate the materials that evaporate at different temperature. Like separating the salt from the salty solution, we can make the evaporation process so it can be separated. When we add 10 grams of salt with the 10 grams of pepper and measure the mass of this mixture, you will find the total mass is the summation of these components. And by increasing the mass of one component, the mixture also will increase. What happened when mixing the vinegar with the baking soda together using a spoon? What happened when mix the vinegar and baking soda together using a spoon? A gas forming, causing the bubbles. So the properties of the substance change after mixing when forming compounds. But the summation of their masses before mixing is equal to the summation of the masses after mixing. The change in the matter, we can say that we have two types of the changes. We have physical and we have chemical. Physical is a change in the matter without the changing in the structure. but the chemical, it's a change in the matter with the change in its structure. So that means in the chemical we can form a new substance and it's not reversible. Okay, while in case of physical, it doesn't form a new substance, and in most of the cases it's a reversible process, that a change in size, shape, and the change of the matter and the state of matter. We have examples: cutting the paper into small pieces, it's a physical; making salad, it's a physical; melting wax is a physical. While in case of chemical, we have burning paper, forming the ashes, that's chemical; making bread is a chemical; some metals can lose their shine, so that's a chemical change. Chemical change, examples for the things that can lose their properties and forming a new substance, like the iron, we can combine with oxygen and water to form the rust. So the rust is a chemical substance called iron oxide that has a reddish color. When the oxygen combines with carbon and hydrogen, they can release the heat and to start the fire. Some evidence to describe the chemical change. First, unexpected color change. So by adding iodine to cornstarch, it will form dark blue color. Second, we have formation of the gas bubble. Adding baking soda to the vinegar produce the bubbles. So that's a chemical change. Formation of a strong odor, like leaving a cup of milk for 2 days or more out of the fridge, they can produce a bad smell. The last lesson is about water desalination. Water desalination means it's a process of removing the salt from water. Like as you can see here in the picture, we have an ocean or a salty water and we want to make it a drinkable water. So first we can make a process called desalination. First we have the filtration, which removes the large materials such as seaweed, shell, and fish. Okay, so making a filtered water. Only water, minerals, salts, and gases can pass through the filter. And next we have evaporation. The next step, evaporation, when boiling the filtered water, the water vapor is raised up, leaving the salts and the other minerals by the thermal energy from the sun. By the action of the sun, it will heat that area and it makes evaporation, which boils the water and leaving the salt and minerals down to go back to the ocean. And by cooling, it's a last step, cooling water vapor, it's turned to liquid water and it's safe to be drinked. So we can say that it's a drinkable water. So here's some problems in making desalination. First, it requires a lot of energy and it's very expensive. It's an expensive process and it requires a lot of energy. Okay, and also it may lead to environment problems such as the small marines, as you can see in the picture, can be hurt due to the sucking of water. And the water could contain a lot of minerals, which could be danger to the marine life after the desalination. So by drinking salt water, that makes the human body dehydrated faster, which means that the human body loses the water faster. Egypt has over 80 desalination plants, so we can desalinate the water to make it drinkable so we can survive in our community. And that's it for this term. See you the next term. Goodbye.